What if I told you that there is a world where monstrous insects rule the land, sea, and skies? And no, I don't mean the annoying mosquitoes that just keep buzzing in your ear non-stop, or the flying roaches we all find impossible to kill. I'm talking about giant, bug-like creatures as large as a dog, dragonflies with wingspans wider than a white-tailed eagle, and insects that buzzed louder than helicopter blades. This, my friend, was Earth approximately 359 million years ago. Scientifically, this period is widely known as the Carboniferous Era. Why, you might ask? Well, first off, have you ever wondered where most of the world's coal comes from? Or even what coal is? The very material that fueled the Industrial Revolution and shaped civilization as we know it today traces its roots back to this ancient world. Now, picture this in your brain. There was absolutely zero human life on Earth. The planet was a hot, humid, and swampy haven, with oxygen levels soaring to about 35%, nearly 75% higher than the levels we have today. This excess oxygen not only allowed plant life to thrive, but also gave rise to gigantic insects and amphibians. For humans, however, the air would have been overwhelming. Quite literally, too much of a good thing. Instead, Earth was a kingdom ruled by plant life and these colossal creatures. The land had its ravagers, the skies their jumpers, and the swamp and seas their kings. And trust me, this was no peaceful reign. But what was it about this period that made it so extraordinary? How did the Earth transform from this swampy, oxygen-rich paradise to the planet we know today? And most importantly, what buried secrets from this ancient time still shape our world in ways we're only beginning to understand? Don't forget to hit that like button, subscribe, turn on post notifications, and share your thoughts in the comments section. Drop a suggestion on whatever topic you'd like us to cover next, and we'll be sure to do that. To understand the Carboniferous period, we need to picture Earth as a massive greenhouse. No, not the cute little one in your backyard filled with tomato plants and succulents. I'm talking about an entire planet wrapped in heat and humidity, a global sauna, if you will. The continents were all in the process of clumping together, slowly forming what would later be known as Pangaea, which is like a supercontinent that existed on Earth about 300 million years ago. So, to put it simply, you imagine all the continents we know today as a giant jigsaw puzzle. That's like Africa, Asia, Europe, North America, and South America. When you fit them all together into one massive landmass, it becomes a Pangaea. So back then, the Earth was mostly like scattered tropical paradises, covered in endless swampy forests, and these weren't your average backwoods. Think dense, unbroken canopies of ancient trees, some stretching over 100 feet high, their trunks as thick as small cars. Beneath this towering greenery, the ground was a chaotic tangle of ferns, mosses, and decaying plant matter. And the air? Oh, the air was a cocktail of life and danger. Remember that little detail about oxygen levels being around 35%? Well, this oxygen-rich environment wasn't just great for growing oversized plants, it also supercharged the development of, you guessed it, massive bugs. Imagine walking through these swamps, if humans existed, which thankfully we didn't, and being dive-bombed by a giant dragonfly with a wingspan over 2 feet wide. Or stepping on something squishy only to realize it's a giant millipede that could grow up to 8 feet long. Clearly, the Carboniferous wasn't just an era, it was nature's blockbuster experiment in size. Let us get back to the Carboniferous. It wasn't all just giant bugs and plants hogging the spotlight. The Earth itself was a land of extremes. Torrential rains flooded the swamps for what felt like an eternity, and the heat created a never-ending muggy haze that hung over everything, making it the perfect breeding ground for the lush vegetation that would eventually turn into the coal we mine today. If you thought the Carboniferous was just a peaceful, leafy utopia, think again. It was an era of survival, dominance, and constant transformation. And the more you learn about it, the more you start to wonder, how exactly did life thrive in such a world? Or better yet, what forces were already at play, quietly shaping the planet for what was to come? Now, let's talk about the stars of the Carboniferous show. its living, breathing, and occasionally creepy crawly cast of characters. Forget lions, tigers, and bears. Those are boring. In this era, nature played by a different rulebook. And trust me, the results were straight out of a sci-fi movie. First, let's look down. Not at the ground, but at the swampy, muddy mess that passed for solid Earth. These swamps were bursting with plants as tall as skyscrapers. Well, at least by ancient standards. Trees like Lepidodendron and Sigillaria stretched to dizzying heights, their scaly trunks shooting straight up into the sky like alien towers. And no, they didn't have leaves as we know them. Instead, they were covered in needle-like structures, giving them an almost otherworldly vibe. These forests were so dense that sunlight barely reached the ground, creating a dark, damp underworld where ferns, mosses, and other smaller plants thrived. But here's the kicker. All this vegetation was constantly growing, dying and decomposing, piling up into thick, soggy layers. This is what would eventually compress and transform into coal millions of years later, a little gift from the Carboniferous to modern industry. Now, let's say you decide to turn on that time machine and travel, maybe a little too far back in time. You step out into the Carboniferous swamps, and the first thing you notice? The ground. It's crawling, writhing, and downright alive with all sorts of multi-legged creatures. Let's start with Arthropleura, the giant millipede-like arthropod that dominated the forest floor. At up to 8.5 feet long and nearly 22 inches wide, this creature was a literal tank of the underbrush. Its segmented body was covered in tough, armor-like plates, allowing it to move seamlessly through the dense, swampy vegetation. Unlike modern millipedes, which mostly munch on decaying leaves, Arthropleura had an appetite for woody plant debris and nuts. Scientists speculate that its size allowed it to navigate the thick, tangled swamp floor efficiently, while its many legs provided stability on uneven ground. Imagine a giant armored version of a modern millipede. Only this one weighs as much as a small dog. But while Arthropleura ruled the forest floor, the skies belonged to Meganeura, the dragonfly on steroids. With a wingspan stretching over 2.3 feet, it was one of the largest insects ever to take flight. Unlike today's dragonflies, which are already impressive aerial hunters, Meganeura's size gave it unparalleled dominance in the Carboniferous skies. Its light but sturdy exoskeleton allowed for effortless gliding, while its massive compound eyes provided razor-sharp vision to spot prey from a distance. Using its powerful spiny legs, it could grab smaller insects mid-flight, making it an apex predator of its time. Think of it as a mix between a modern dragonfly and a hawk, only buzzing instead of screeching. Moving on, let's dip into the waters, where Eogorinus, the dawn tadpole, reigned supreme. At a whopping 15 feet long, this amphibian resembled a modern crocodile, but was even more eel-like in its movements. Its long, sinuous body, powered by strong tail muscles, made it an agile swimmer, perfect for stalking prey in murky Carboniferous swamps. Its broad, toothy jaw was built to snap up fish and smaller amphibians in an instant. Picture a mix between a crocodile and a giant salamander, lurking silently in the water, waiting for the perfect moment to strike. Also in this marshy lowlands, you might come across Diploseraspis, a horned amphibian about 3 feet long. Its head was shaped like a wide, flat triangle, and it used this unique feature to bury itself in the soft mud for camouflage. When prey, like small insects or fish, wandered too close, Diploseraspis would strike with startling speed. Modern amphibians like the horned frog or axolotl share similarities, but none can match the size or striking power of this ancient ambush predator. Back on land, you'd encounter trigonotobids, early arachnids that predated modern spiders. Though they didn't spin webs, they had a sturdy exoskeleton and long legs, built for traversing the dense forest floor. These creatures were about the size of a modern crab and had strong mandibles for crushing insects. Their ability to move quickly through leaf litter made them effective hunters, comparable to today's wolf spiders. And then there was Pulmonoscorpius, a prehistoric scorpion that could grow up to 28 inches long, essentially the size of a house cat. Unlike modern scorpions, Pulmonoscorpius had thick, spiked pincers and a venomous stinger the size of a small dagger. It likely hunted small insects and amphibians, using its powerful claws to grab and crush prey before delivering a venomous sting. If you've ever squashed a scorpion in your house, imagine one big enough to wrestle a small dog and win. This next creature you might mistake for a modern seagull or even a small hawk, but this was Campylognathoides, a primitive flying reptile. Though technically a relative of the pterosaurs that would dominate millions of years later, it already boasted impressive elongated wings and hollow bones, allowing for agile and efficient flight. It was an opportunistic hunter, gliding through the thick air to snatch insects mid-flight or scoop small fish from shallow waters. Think of it as the prototype of aerial hunters, a living blueprint for creatures to come. Finally, there's Adelogyrinus, a small eel-like amphibian that slithered through the swamp waters. At just under 3 feet long, it wasn't the largest predator, but its streamlined body and quick movements made it an effective hunter. Adelogyrinus relied on stealth and speed, using its snake-like movements to dart in and out of vegetation while avoiding larger predators. Think of it as a primitive cross between a snake and a newt. But the real game changer? Right toward the end of the Carboniferous, something incredible happened: the emergence of the first reptiles. These pioneers had scaly, waterproof skin and eggs that could survive on dry land, giving them a massive advantage over their amphibian cousins. It was the beginning of a whole new chapter for life on Earth. Among the first reptiles to emerge from the Carboniferous shadows was Petrolacosaurus, a sleek lizard-like creature about 16 inches long. Its lean, elongated body was perfect for darting through dense foliage, while its sharp claws and agile limbs helped it climb trees and escape predators. Petrolacosaurus's sharp teeth and insect-heavy diet made it an early version of today's monitor lizards, or even a small Komodo dragon. But what set it apart was its ability to lay hard-shelled eggs, a game-changing adaptation for surviving away from water. Also among these reptiles, creatures like Hylonomus, the first known reptile, made their debut. These pioneers were small, about the size of a modern gecko, but their adaptations were revolutionary. With scaly, waterproof skin and the ability to lay hard-shelled eggs on land, Hylonomus could thrive in environments where amphibians couldn't. They were the blueprint for reptiles to come, paving the way for dinosaurs and eventually modern lizards, snakes, and even birds. From the massive arthropleura crawling through the underbrush to the winged Meganeura ruling the skies, and the crocodile-like Eogyrinus stalking the waters, these creatures and many others created the cycle of life in the Carboniferous Era. But not all creatures were as gigantic and fearsome as the ones we've discussed. The era also had its fair share of bug-like and tiny spider-like insects, such as Eophrinus, Anthracomatus, Aphantomatus, and Idmonorachne. Some of these creatures represent the ancestors of modern arthropods, and their evolutionary legacy persists to this day. For instance, the Eophrinus, a small arachnid-like creature, closely resembled modern-day whip spiders, while others laid the groundwork for the development of insects and spiders that continue to thrive in our world today. Now here's the sciencey bit. Don't worry, I'll keep it simple. During the Carboniferous, plant matter didn't decompose like it does today. Why? Because the fungi and microbes, which is what normally break down dead plants, hadn't evolved to handle the tough, woody materials these ancient trees were made of. Instead, dead plants got buried in swamps, layer after layer, squeezed under immense pressure until they transformed into coal. And voila! The world's first major energy source was born. Fast forward to today, and that coal is what fueled the Industrial Revolution, powered our factories, and, let's be real, caused a few climate issues along the way. So, yeah, the Carboniferous left us quite a legacy, a gift wrapped in both opportunity and consequences. But coal wasn't the only thing the Carboniferous cooked up. Let's talk about the air. With all those plants photosynthesizing like crazy, They sucked a massive amount of carbon dioxide out of the atmosphere and replaced it with, you guessed it, oxygen. This supercharged the air, creating an atmosphere with oxygen levels about 75% higher than what we breathe today. Great for bugs and plants, not so great for potential forest fires, which were more common than you'd think. And here's a fun twist. All that CO2 storage in plants contributed to a cooling effect on the Earth's climate. As the Carboniferous drew to a close, temperatures began to drop, the swamps dried up, and the stage was set for one of the biggest ecological shifts in Earth's history. So if you've ever held a piece of coal or seen it burn in a fireplace, you're literally touching history, a relic of the Carboniferous period. That shiny black rock? It's not just a chunk of Earth's crust. It's the compressed remains of ancient forests that grew, died, and piled up over millions of years. Think of it as nature's way of recycling on an epic scale. But as we've seen time and time again in Earth's history, nothing lasts forever. So what brought this lush, swampy paradise crashing down? As with all things in Earth's history, the Carboniferous period wasn't built to last. What started as a lush, oxygen-rich wonderland eventually began to unravel, leaving behind a very different planet. So what happened? Toward the end of the Carboniferous, Earth started to cool. Remember those giant tropical swamps filled with towering trees? Well, they began to dry up as the planet experienced shifts in temperature and rainfall. Scientists call this the Carboniferous rainforest collapse. And trust me, it was as dramatic as it sounds. Massive stretches of dense jungle simply withered away, leaving behind fragmented ecosystems and a lot less room for the creatures that depended on them. This shift wasn't just bad news for the plants. The animals that ruled the Carboniferous, the giant insects, amphibians, and other swamp-loving species, found themselves out of luck. With fewer swamps and less humidity, their populations began to dwindle. Some went extinct, while others adapted to the changing landscape, paving the way for new kinds of life to take over. But wait, there's more. As if drying swamps weren't enough, tectonic activity during this time added even more chaos. The continents continued their slow-motion collision, pushing up mountains and reshaping coastlines. This meant even more changes to the climate, habitats, and the availability of resources. And here's where things get really interesting. Right as the Carboniferous period faded into history, the stage was set for the next big thing, the Permian period. It was during this time that reptiles, those hardy survivors of the Carboniferous, truly began to rise. With their scaly skin and ability to lay eggs on dry land, they were perfectly equipped to thrive in the drier, harsher conditions that followed. These powerful creatures became the early prototype for the dinosaurs of the Triassic and Jurassic era. So, what's the takeaway? The Carboniferous was an era of giants and lush abundance, but its end became a reminder that even the mightiest ecosystems can fall. As the lush forests turned to coal and the air itself began to change, Earth once again transformed, setting the stage for the evolution of new life and the beginnings of a very different world. So next time you're afraid to kill that roach that's living rent-free in your home, just remember that they're a far cry from how they used to be.